Okay, well, my clock says it's 7, so I think we should get going. No time like the present. To everyone here already, thank you for showing up, coming and being an enthusiastic participant and often overlooked because of how complicated it is discussion. I'm very excited to have the excellent panel of specialists that we have here today. I'm very excited to be able to ask them questions and learn from them and hear about their experience. Thank you to everybody here from CRHNet that has helped put this event together. I want to make sure that everybody here knows that this is being recorded. You will be recorded. So if you're not comfortable with that, then fair warning, it is happening. Also, I want to make sure that everybody knows that this is a respectful and safe space. We're not interested in any kind of hate speech. It will not be tolerated and you will be asked to leave. And other than that, I think we should just get going. So thank you, Nathan, for sharing your screen. Is there anything that I've forgotten? Oh yeah, my name's Willow. I'm Willow. That's me with the sunglasses on. I am a student at York University, and that's pretty much all you really need to know about me, I guess. I'd be happy to help you if you have any technological questions during this event. All right, what's the next slide, Nathan? Okay, so yes, this is a discussion about ENSO. We're going to be talking about the switch from La Nina to El Nino this year. I guess it's kind of still up for debate depending on what part of the world you ask about whether or not it's coming. But everything that I tend to read says that it's on its way here and that it's going to be a very big, intense year for El Nino. So we're going to talk about that and about what that's going to mean for Canada and for the world at large and how it's going to affect potentially climate change and climate events and weather disasters and weather events. So let's start with an introduction from each of our panelists. If you guys can take the floor and give us a little bit of talk about your background, who you are, and why you're here. That would be excellent. So Jim, the floor is yours.
So I'll start since my picture's up there. Hi, everybody. A real pleasure to be here. While I've been a member of CRHNet for a number of years, I've been more involved with the Canadian Meteorological and Oceanographic Society. I'm a meteorologist. I've spent my career with Environment Canada, doing a number of jobs from Whitehorse, Yukon to Halifax, Nova Scotia, where I now live. And but my passion is around extreme weather. I do a lot of work with the insurance industry and the reinsurance industry still, even after my retirement. And what I'm best known for is starting the Canadian Hurricane Research and Forecast Program. And in behind me in my little picture, there's a picture of Hurricane Juan, which certainly was a significant event here in Halifax. And we actually flew into Hurricane Juan, and then we did overflights afterwards with some storm studies and storm damage. So certainly a pleasure to be here.
Thank you. Thank you very much for being here. Nathan? Dr. Agrawal, would you mind taking the floor and giving us a taste of who you are?
You didn't notice my picture was up there already. Hi, pleasure to be here. So my name is Niru Agrawal, in short, Niru Agrawal. I am a professor of disaster emergency management at York University with the program by the same name. By training, I'm a hydrologist. So I have a lot of interest in the science of disasters. I've done studies on, I used to do flood, rainfall runoff modeling, so flood forecasting, and the holy grail all my life has been real-time flood forecasting. So how do we know when the rain is falling? We know the precipitation, how heavy it's going to be. Can we predict the floods right after that, urban flooding especially? But as long as I've been with the program, I'm happy to actually expand my knowledge to all hazards, especially water related. So floods can occur due to hurricanes. And then when you talk about hurricanes, I got interested into Southern oscillations, and the history that I will talk about later goes back to where I come from, India. during British time, when they were ruling India. So I do a lot of work on floods. I've done a ENSO related study on Rideau Canal, the skateway in Ottawa. So it's, how we talk about just the temperatures and humidity, you can say the precipitation temperature, and then we think that weather can be predicted. So I've published a paper illustrating that actually Arctic oscillation and North Atlantic oscillation should be taken into account to enhance the confidence in the predictability of the temperature itself. So there you go. That's my interest in ENSO. Thank you for the invitation.
Excellent. Thank you so much for being here. That's very neat about the Rideau Canal. I didn't know that. So close to home. All right, Dr. Patricia Martel, would you
Hi,
please
everyone.
tell us about yourself?
So I actually have been working in the field of emergency management for over 15 years at this point in time. I originally started in the physical sciences with a focus on natural hazards, especially severe weather. That was my primary interest, especially tornadoes. I've lived all over, so I've actually experienced the impact phases of a lot of emergencies, earthquakes, tropical storms, and especially tornadoes. I lived in Colorado for a period of time, and that is what really kind of sparked my interest for severe weather. And that aligned really well with my interest in emergency management, because when I started out, there weren't degree programs available in Canada for emergency management. So that really pushed me towards physical geography and earth sciences. I couldn't make up my mind between meteorology and other hazards. So I figured, let's go for a broad approach. So I got that on the ground experience. And eventually when I did my PhD, that got me thinking, okay, I know the how. How do physical hazards occur? I don't know the why. Why do people react in the ways they do? Why do they ignore the warnings? Is it that they ignore them, or do they simply not understand? So I went for a PhD where I looked at the human side of things to try to get a more clear picture of what's going on and how do we improve the messaging we do? How do we build stronger plans, so that I have that background. I'm also a past president of CRHNet too, so I love coming out and supporting these things. So right now I'm actually with Niagara region, where I'm the CMC. In Ontario, that's the Community Emergency Management Coordinator. If you're from Manitoba, that would be the MEC, the Municipal Emergency Coordinator. And in other areas, you likely have a similar position. They run the emergency management program for the municipality or the community.
Excellent. We're lucky to have you. Thank you for showing up.
It's great to be here.
Dr. Kaz Higuchi, you're next. Before we bring your slide up, though, I just want to say I forgot to ask everybody if you could keep yourself.
No, I don't have any
muted.
slides.
Oh, I just mean a little intro slide we put together for you from the bio you gave us. But yes, if you're not speaking, if I could ask everyone to stay muted, I think pretty much all of you are anyway. I just forgot to mention that earlier. So, and with that, Kaz, would you mind telling us a little bit about yourself?
Yes. My undergraduate education was in basic physics, while my graduate studies at the University of Toronto focused on atmospheric physics. Right now, my academic and research interests have focused on complex systems dynamics, with a focus on Earth system as a non-linear complex dynamical system, particularly on what we call low frequency variability modes. That includes ENSO, NAO, Arctic oscillation, Pacific indicator oscillation, those type of variability modes, which are quite prevalent in dynamical fluids. At York University, I have taught courses in climate change science and policy and hydrometeorology. The course that I'm teaching for last over 10 years now in the DEMS program is quantitative methods, which with introduction to basic statistics, leading to a conceptual appreciation in the application of extreme value statistics for characterization of extreme natural events such as flooding and earthquakes, and that can be that can lead to disasters. So that's where my involvement in the disaster management comes in, and I also had a sort of personal experience in looking at what the tsunami did back in northern Japan when I was a visiting scientist at the Tohoku University in Sendai, and there I met 2 or 3 geophysicists who have been looking at the earthquakes and other sort of natural disasters. And what they told me at that time was basically it wasn't really the earthquake itself, but it was the tsunami that did the damage. And if you look at the buildings at the Tohoku University, which is located on the top of a small mountain, there was actually no damage done to the building, even though the earthquake was quite significant. So it was the focus of the disasters in Japan it's not so much on a tsunami thing, but it was earthquakes, because they have a lot of earthquakes. But that disaster back in, was it 2012 or something? It was amazing that now they've shifted to the tsunami after the event, and they've been applying various strategies to mitigate any further or future damages from the tsunami event. So it's amazing how things, if you experience something, you try to respond to it. And I often joke to my Japanese colleagues is the fact that for geophysicists, Japan is sort of like a world of what's the best word for it? But it's basically sort of like a utopia for disasters. That you live in a sort of day-to-day disasters, from hurricanes, from earthquakes, from tsunami, and but if you look at their strategy in terms of buildings, kind of buildings that they construct, it's they have quite a successful story in that, and based, and I don't know if Niru remembers or not, but there was a presentation at the York University where a visiting scientist from Japan talked about what had happened, and they emphasized communication at that point. The communication as to how the resources have occurred was really fantastic. You really need to improve that communication. I know, and I guess Jim and Patricia are sort of focused on this communication of a quick communication of the impending disaster. So I think that's really an important factor in addressing disaster management. I think I talked enough about this.
That's a great point. Thank you for ending it there. I think that's a great transition, because next, thank you all for introducing yourself. And next, we're going to have Jim give us a little presentation on ENSO and how it works. I think that some of us are probably really familiar with the dynamics, but it's also very complicated. And I know I myself, even though I've been thinking about it for weeks, constantly forget all of the specifics. So in an effort to allow us to communicate with one another better, let's all listen to Jim for a little bit and hopefully get some better understanding of what it is we're about to be talking about altogether. Oh, Jim, you are muted.
Yeah, thanks, Willow. Is my slide showing up there okay?
It is, yeah, I think for me it is. I assume for everyone
Perfect.
else as well.
Okay, awesome. So I just want to put a plug in for our annual meeting, and we do a lot of conversation around extreme weather at the Canadian Meteorological and Oceanographic Society. Chris Fogarty is the current manager of the Hurricane Center, and so we'll be talking a lot about Hurricane Fiona in Newfoundland at our annual meeting at the end of May. And Hurricane Fiona the name was just retired today by the World Meteorological Organization. So let's start a little bit about El Nino and La Nina. Dave Etkin shared the slide with me. El Nino meaning little boy or Christ child in Spanish. The South American fishermen actually first noticed that there was periods of unusually warm water in the Pacific Ocean. And so they named it actually El Nino de Navidad, because El Nino typically shows up first around the month of December, so Christmas time. La Nina correspondingly is little girl in Spanish, and it's sometimes referred to as other names, El Viejo, Anti-El Nino, or simply a cold event. I'll show you a few slides on why one is warm and one is cold. So let's start with the circulation of the atmosphere. Basically, a lot of what we see in winds and atmospheric circulation and storms is really all about Mother Nature trying to maintain a balance. But since the sun is always overhead at the equator, the oceans warm up, certainly much higher in the equator areas, in the tropics. And over the equator, the warm air rises. And when it rises into the upper atmosphere, it moves poleward. That sets up a kind of a broad circulation of highs and lows, where the pressure on average is lower at the equator, lower in the mid latitudes where the storm tracks are, and higher in between, higher in the poles where the air is colder, and also higher in the subtropics. If you think about the Bermuda high, that's a reflection of the higher pressure in the subtropics. So the key outcomes of this is, with the high pressure just north of the tropics and the low pressure along the equator, generally the winds are blowing from high pressure to low pressure, and because of the Coriolis force, they turn right. And in the northern hemisphere, and they turn left in the southern hemisphere. They converge along the equatorial bands on either side of the equator, and that results in convective weather. Certainly anyone who's flown over the equator, you go through a period of turbulent thunderstorm kind of activity, flying from the northern hemisphere to the southern hemisphere. North of the high pressure area, you have the mid-latitude westerlies. And as I said, it's the southeasterly or easterly trade winds generally along the equator. So if you look at a little graphic of this, you've got the high pressure in the subtropics, the mid-latitude westerlies, the polar vortex or the polar cell, and then you've got the easterlies or northeasterly and southeasterly trade winds, generally easterlies along the equator. And it's really that wind pattern that sets up the El Niño-Southern Oscillation. So under normal conditions, you've got these easterly winds, and this is a phenomenon in the tropical Pacific Ocean. So South America is here, Asia is over here, Australia. The winds typically on average are from the east to the west, and that moves the warm water from the eastern side of the Pacific to the western side. So the warm water kind of piles up more so on the western half of the Pacific Ocean in the tropics. There's upwelling, so colder air, colder water coming up from the deeper waters. And so the water temperatures are somewhat cooler in the east, warmer in the west. You've got warm water here, so the air is rising more so, it's moist. And so you end up with rainier convective kind of weather in the western part of the tropical Pacific, and you get this circulation set up where you've got subsidence or descending air on the east, and descending air is more associated with drier weather, warmer kind of arid kind of situation. La Nina is essentially an intensification of these normal conditions. So when the winds are stronger, the upwelling is more significant. The temperatures are cooler in the east, much more than under normal conditions, and much warmer in the west. And so it's warmer and drier than normal, and certainly moisture and significantly wetter in the west. And then the El Nino conditions are when the pressure gradient is rather weak, the winds are rather weak. In fact, in some cases, rather than going from the east to the west, they're going from the west to the east, and the circulation is the opposite. The warm water is more equally spread out. In fact, in some cases, it's even warmer sometimes relatively in the eastern part of the Pacific. So you get rising air, heavier precipitation events. The circulation is set up, it's drier and warmer in the western part of the Pacific, and the circulation is exactly the opposite of the La Nina event. These oscillations they vary. They're not terribly predictable, as I think Willow suggested, that we're not really sure when it's going to transition from one to the other, but on average, it's every 2 to 7 years. And so there's a teleconnection. So basically, it sets up an atmospheric pattern of ridge and trough around the globe. Most of the impacts are along the equator. In the wintertime, our wintertime, so December to February, we get impacts certainly on the West Coast and along the southern parts of the USA. In our summer and the Southern Hemisphere winter, the impacts are largely on in the Southern Hemisphere. Just a blow up of the El Nino pattern. Warmer in the west, and the jet stream further south, and then kind of drier and cooler in the southeast, wetter in the southwest. The El Nino, for me as a hurricane forecaster, we look at this a lot. Fewer hurricanes because of wind shear that's set up in this lower jet stream in the Atlantic, but more hurricanes because the water temperatures are higher in the Eastern Pacific. So it certainly affects the hurricane activity. But in 1992, Hurricane Andrew hit Florida, and it was during a El Nino event. La Nina, the teleconnections are kind of the opposite. So blue is cool, brown is dry, and so it's certainly a more cooler pattern, consistent with it being a more cooler event in the ocean. And as I said, it affects the tropics and the northern hemisphere in the winter, our winter, and then the southern hemisphere correspondingly impact during their winter. And just to blow up on that, a cooler kind of situation in La Nina pattern, wet. So we had La Nina certainly at the beginning of our winter and for most of our winter, and undoubtedly it was cool, still is in much of Western Canada. Very wet along the West Coast, and certainly some tragically wet situations in California. The teleconnections on the part of the country where I live are certainly much weaker. La Nina, more hurricanes in the Atlantic, fewer hurricanes in the Pacific. So it's kind of an opposite effect. Tornadoes, there's not a strong signal for tornadoes, but La Nina, the pattern is more likely to get tornadoes, so kind of the purples are above normal, the browns and oranges are below normal. La Nina is more likely than El Nino to have a tornadic activity, but these are kind of averages. This is a little animation of December into early, just into the first part of the spring. And you can see already the warm water starting to show up off the west coast of South America. The blue is cool. The reddish browns are warm. If I go through it again, it starts off in December as cool, and you can see the warm pattern setting up. That's the El Nino setting up already. So in fact, that's certainly consistent with the prediction for a El Nino year. What's interesting when you combine El Nino Southern Oscillation and climate change, there is definitely a pattern of warmer global temperatures in the red dots on average during an El Nino event, cooler on the cooler side of the global warming curve on the La Nina side. And so we're looking at this year, in fact, if it is an El Nino, we'll be a little bit more above normal on top of the climate change signal. And so this little cartoon is from the National Weather Service in the States. El Nino plus climate change, what does that mean? A headache. So El Nino affects the variability in the climate, certainly extremes in certain parts of the globe. Climate change, weather and climate extremes both. And so if you add climate change plus El Nino, it enhances that variability and probably enhances some of the extremes. Where that's going to happen, that's the uncertainty. And certainly that's some of what we're going to talk about today. So we'll move on. I'll stop sharing my screen and we'll move on to some questions and some discussion.
Thank you so much. That was excellent. For the question and discussion period, I'd like to ask that if you have a question, please ask it, but raise your hand if you can, and we will get to you and call on you. To start it off, I would like actually to ask you, Jim, if I can be so bold as to be the first person to ask a question. Could you explain just a little bit about why there is concern about the switch to El Nino when it sounds, if you're just listening to the explanation of it, it sounds kind of like El Nino and La Nina are the same things, but for different parts of the world. So why are we concerned about this switch specifically?
Well, personally, the fact that on top of the last point I was making, having above normal Pacific temperatures on top of the above normal global climate warm temperatures. First of all, additional heat in the Earth system adds more energy to storms on average. So whether or not there's more or less hurricanes, the hurricanes that do form may still be more powerful than normal because the sea surface temperatures are above normal. In fact, there was a story today in the Nova Scotia news about the above normal sea surface temperatures here in Atlantic Canada. The other thing is that for every degree of above normal, there's 7% more moisture in the atmosphere. So if El Nino plus the already 1 point whatever temperature we are globally above normal, there could be as much as 10 or even 15% more moisture in certain parts of the Earth. And so when there's a storm, it's squeezing more moisture out. So it perhaps we're going to be at the risk of heavier precipitation events where those storms do occur. So it's kind of enhancing some of the extremes because of warm on top of warm.
Interesting. Okay. Thank you. It's like weather events caffeinated. Okay. Excellent. All right. So yes, please, let's open it up to the floor. Feel free to ask any questions that come to your mind. Let's challenge these panelists. Let's make them speculate. Let's make them think back to all of their years of experience and get things going. Nathan, are you curious?
Yeah, this is a question for Patricia Martel. I'm wondering, from your experience as a local CMC, what are the impacts that you expect to see local regions and the practical things that we'll actually be seeing over the next year?
So that's always hard to tell, because when we're looking at a small area, larger patterns are difficult to figure out if they're going to apply to us, right? Because when you're a local CMC, if you're the one area that gets that tornado, well, you're the unlucky one, right? Because as Jim showed you the map, you're less likely to see a lot of tornadoes during an El Nino year. Well, that's not a lot of comfort if I happen to be the one who gets one. Knock on wood, we've had enough bad news with weather so far in the last few months with Niagara. So at the local level, we take this along with the seasonal forecast to heart. We do pay attention to it, but at the same time, we have to always be looking for all possibilities, right? So it gives us an indication that we need to be aware, okay, things might be more intense for, say, if I was on the West Coast in particular, forest fire season. I'd be looking at that in particular and thinking, oh no, we could be in for a really, really rough one. And looking at the cascading hazards that can come from that too, that gives me a good idea of that, okay, not only do I have to keep in mind that forest fires could be an even greater threat than usual this year, I have to look at the other hazards that could come out of that, because following a forest fire, when you do get rain, what other hazards happen out of that? Increased risk of landslides when you do get rain can follow that. So it gives you an idea of what might come from it. So we still have to look at all the other hazards that can come and hit us with full force, because if I happen to be the unlucky one, I still have to deal with it. But I'm definitely going to look at the hazards associated with an El Nino year and go, okay, I have a higher frequency and probability of these certain hazards, and let my communities in particular know this year that, okay, you might want to increase your public education around these particular hazards.
Awesome. Norman from HEMBC has a question as well. Norman?
There you go. Hello again.
There we are.
Just a general question here, because we hear this, we anticipate this from the various elements of that there are changes anticipating, but drilling this down a little bit more from a emergency management perspective is that based on the current forecasting tools that we have, trying to find out who do we listen to with more confidence, how far ahead can we forecast a hazard weather event during a potential transition? So the more lead time we have, the greater preparedness we can have. Or are we looking that it's going to be, again, a short notice event?
So I can start with that. Depends on the scale of the event. So if you're looking at a heat dome, which certainly affects the health and air quality of folks on the West Coast, a heat dome is kind of a large-scale event driven by the large-scale circulation of the atmosphere. So that event is actually significantly more predictable than a short fuse and small scale event. So we use what I refer to as ensembles. So it's a number of weather models, all with slightly different starting points. And you look at maybe an ensemble of 50 models, and you look at the variability and the predictability over a 10 or 15 day period. And a significant heat dome event or a cold event usually is decently predictable within 10 or 15 days. You can see that trend in those ensemble predictions. When it comes to a small scale event, whether it be a tornado or a heavy thunderstorm or squall line, that event is the pattern that might produce that event is predictable within 7 to 10 days, but the actual occurrence of that event may actually be only in the minutes because it's only affecting a very small area. So the scale of the event it contributes significantly to the lack of predictability.
Does that answer your question, Norman?
Yes, I was able to narrow this down for me because when we start looking at modeling and weather forecasting from a layman to the subject matter experts, we often grab the 14-day or the 10-day advance prediction or forecast, and we start putting things in place there. It's just that when you're looking at something that is as significant as a change in a global pattern, you try to anticipate more, and then sort of this year or last year showed that climate change has put in a very large wild card that we've never had tornadoes in BC that I've seen or heard, and all of a sudden we had to. So when we start looking at our hazard profile, it has grown and changed. And now that we've had a significant amount of heat domes and fires, again, our flooding hazard has changed. So when we start looking into what did we prepare for and what are we preparing for, it has changed, it has developed, and we're just trying to catch as much lead time in catching up so that we are best prepared. So no, I appreciate the answer. Thank you.
And Norman, I'll just add to that because the point you raised and how you articulated it is really, really well done. I organized a panel discussion around the BC events at our annual meeting last year. And the question I asked, and this is the question for you folks, how do you prepare the public for an event they've never experienced before? And that's what we're dealing with.
That's a great point, Jim.
We'll get right on it. Thank you. I see that Armel has a question.
Hi, can you hear me? See me? Yeah.
Sure can.
I just wanted to add to Jim's answer. I work as a warning preparedness meteorologist with Environment Climate Change Canada, and Norman and I have spoken about this as well. There's also some really interesting nuances to the patterns that we see and what is predictable in those environments. And you only look 4.5 months after the heat dome, the quote unquote heat dome of 2021, and you see the atmospheric river of a scale probably a 4 out of 5, if not a 5 out of 5 on the West Coast, and the cascading hazards that come from it. And that is, of course, a fairly big event in terms of its scale. It reaches down to the subtropics. It's several 100 kilometers in width and many thousands in length, and yet it's only really affecting a little part of the coast. And the nuances of that event are so incredibly important that make all the difference, right? They were projected to hit, much more into the Washington state side, and only on, the eve of the storm were we seeing the, the push just ever so slightly north, and therefore it goes from, a 24-hour event of heavy rain to more of a 48, 54 hours. And that's something, unfortunately, for folks like Norman, people on the ground who are having to make really important decisions months ahead of time, years ahead of time, and also days and hours ahead of time, very, very difficult, because there's only so much you can say, and you can't always say, well, there is an outlier chance, speaking of the ensemble information, there's an outlier chance that, that worst case of that magnitude is going to occur, because you would be saying it virtually for almost every winter storm on the West Coast during that span of, sometimes it's 6 or 8 or 10 weeks long, where things are tremendously active. And so we also hear from the Normans and the emergency management folks in BC and the other provinces, territories, that you cannot over alert. And so that brings me to just my final point that I think might be interesting for everybody here, is that we need to better articulate confidence or certainty in the forecast. So when you do have that pattern that Jim spoke about that, you know, looks amazing, you're 10 days out, you're saying, yep, it's going to be hot, and we'll tell you whether or not it's going to edge towards an emergency or just a regular kind of hot. That's something you can say with high certainty, and you say so. In the meanwhile, you also need to be able to say, well, you know, we're looking at the next 12 hours, like this, the convective cycle of today. Tomorrow is yet another beast, and we'll be analyzing that one overnight as a forecasting entity. And therefore, what are the implications? So there's that whole element, I think, is something that we're emerging into as a public weather agency, and I think other agencies as well, in terms of communicating on that level. I'll leave it there. Thank you.
Thank you for that perspective. Niru?
Yeah, I just wanted to pick on that outlier angle of what Armel just articulated. So there have been only the last consecutive 3 years of La Nina conditions have occurred in the past in 1954. The records have been kept on these conditions, La Nina, El Nino, since 1950. And the one that's the 4-year consecutive period, similar to the one that we are experiencing now since 2020, was we experienced in the past in the 1973, so 1970s, you can say. And the next one was 1998, when we also experienced the Eastern Coast ice storm, the severe storms. So all that is to say that we know that if there is a consecutive years after years after years, 3 years of La Nina conditions persisting, we can expect atmospheric river events to occur. So that knowledge should be there when you're planning for it. So when we are watching, the conditions are persisting. The other thing about that is that when you know that the atmospheric river, like you said, weeks in advance, we should know these weather systems. They are coming in, and we should anticipate that they are coming. But on top of that knowledge, and the uncertainties around that, how to predict exactly where it's going to make a landfall, whether it's atmospheric river coming with a lot of moisture, or is it any other event, tornado, rainfall, anything. But that has to be, so then we have to look at the large scale circulation, oscillations, what we are, the topic of today, ENSO, Southern Oscillation, Arctic Oscillation, North Pacific oscillations, all these things. So what I'm trying to say is all these different phenomena, they need to be studied together to be able to enhance the confidence in the predictability, in the predictions. So I'll stop there.
Thank you. Patricia?
So I think there are two groups, and I recently talked with Environment Canada, our warning preparedness meteorologists here in Ontario, about it. There's the emergency managers group, and we just went through, we're calling it a blizzard, but it really was a multi-hazard event here in Southern Ontario. Southern Ontario and parts of Eastern Ontario got a blizzard. Here in Niagara, 3 of my municipalities got a multi-hazard event. It was like we had 3 seasons in the span of less than a week. It was wild. We had a blizzard that lasted for more than 24 hours with insane wind speeds. I believe we had wind gusts of about 110 kilometers per hour for about 24 hours. Environment Canada can't actually get snowfall estimates because the winds were so intense for it. We had to rely on the US. But we also had our typical fall storm during that period that gave us a seiche on the lake with storm surge. And then we had our typical spring melt during that time as well, just to make life really, really interesting. And through all of that, Environment Canada and our warning preparedness meteorologists were critical throughout that. Now, I may have a background in weather. I have nothing compared to these guys. And being able to call up our Storm Prediction Center and get information for those affected municipalities, because of course this had to happen right over Christmas. They were essential. And I told them flat out, they saved lives during that, because on top of all of this, we got a flash freeze, a dramatic one. So imagine if you're driving an ambulance full throttle down the highway, and we had several, and all of a sudden, very quickly, things turned to very icy conditions, because you could actually see this one coming. It was very neat, with very high winds and see heavy rain intensely turn to snow. Environment Canada was able to give us the time period for that. There was uncertainty with this one. We knew it was going to be really bad. They issued the watches and warnings. They actually had messaging saying a crippling blizzard would be expected. They issued a blizzard warning. However, because I was an emergency manager and because they knew I was looking at worst case scenario, they know when I call that I understand probability. I'm not going to be upset if the worst case scenario does not happen. In fact, I told them I will do a happy dance if that doesn't happen. And with that understanding, that's how we move going forward. And it's been a very productive relationship, because this way, like, I'm able to warn my 12 municipalities, I'm able to warn my first responders, and I act as kind of a conduit, and I put the information I get from them into language that I know my fire chiefs, my police will understand. And I've been working with all of them to actually understand the probability behind it, because that's a thing that I find a lot of people struggle with in the public. They take the weather forecasts as absolutes, even though, I mean, they have percentages attached to them for daily weather. And it's a struggle, right? Because with the weather, there's so many minor things that can have a significant impact on accumulation, precipitation type. But they don't understand the amount of work, the variables that go into it, the uncertainties. They don't understand its probability. And I've got to tell you that over time, at least with my group of emergency management stakeholders, we've actually seen a shift in mindset over it. So maybe about a month ago, we actually had the potential to have a pretty significant freezing rain event that was going to impact us here in Niagara. We were looking at pretty significant accumulations that could have caused widespread power outages. We talked with Environment Canada. They provided us with a pretty detailed forecast for our area. Then we got lucky. Despite the models actually being in considerable agreement and with fairly high confidence, the precipitation actually moved towards ice pellets at the last minute. And you know what was the reaction of my emergency management partners? They were happy. There was absolutely no bashing of Environment Canada. There was the understanding that the meteorologists did their jobs properly. They were grateful that Environment Canada provided them with all that. They now have a better understanding of probability and what goes into it, because we've worked with them over time. So it is possible to achieve this. It just takes understanding and a lot of work to overcome where some of the issues are. The public are more complicated though, and that's where we need to talk with them and understand how we work around these biases that exist.
Thank you for that. Michelle?
I guess I have a concern about major events following, for example, the derecho that happened here in Ontario, where we had a major tree loss, like a large swath, just literally decimating just towns of huge forests of trees. And even Northern Tornado Project was trying to track all of the different impacts. And when you get that major tree canopy loss, you get sometimes, especially in suburban and urban areas, that kind of urban heat island heat that happens in the summer when you had large swaths of trees lost. It happened after our 2013 ice storm in Brampton. And then the subsequent summers after that were just ridiculous. We were getting heat emergencies earlier in the season than we've ever seen before. And So I'm wondering if this trend might happen with this El Nino, because I believe one of the El Ninos was 2014 to 2016. So if we had an ice storm in 2013 and we had ridiculous summers following that, because of the tree loss, it impacted us pretty hard during that ice storm. Are we going to start to see some of this concern happening with some of our cities, where we're having hotter summers and where we're going to have to do a lot more preparation for example, extreme heat alerts?
So I can start because the heat thing is extremely important, Michelle, and certainly how we design our cities. It's like some things we have to do with 50 years anticipation. Some things like mitigation for heat and mitigation for flooding, as an example. But the heat, I did a presentation on the weekend for a church group. They were really concerned about changes in the environment. And here in Atlantic Canada, which one would consider to be a relatively mild summer, not terribly hot, things are changing. People are getting heat pumps because of not the energy savings. They're getting it because the summers are much warmer. And typically in Halifax, we normally get 1 or 2 30-degree days in a year. In 30 years from now, we will be getting 20 30-degree days in a summer. So these kind of numbers are extraordinary. And I showed them the map of the heat dome, and the 49.6. Armel would know better than I for Lytton. You're absolutely right, Michelle. The readiness for extreme heat, especially in urban areas, and the identification of vulnerable communities is such an important and significant challenge during these events. I asked the folks at the talk I gave, what's the largest loss of life in the history of Canada due to a weather event? And very few people, nobody knew that it was actually the heat dome in 2021 in the Lower Mainland. The other thing that, with respect to downed trees, and I can comment on that here in Atlantic Canada because of Fiona, the subsequent summers after a significant wind event actually adds to the forest fire risk. And so the wildfire risk actually is enhanced after a large derecho or a hurricane in the case of Hurricane Fiona. And so this cascading, as we've been talking about, of risks and impacts is certainly another consideration associated with the heat. Thank you.
Thank you. I just want to note that we are getting close to 8. This is a great discussion that's happening, and I would personally love to see it continue, but I know that some people might have other places that they need to be. All of our panelists are very important and busy people. So if you can stay, we'd love for you to be able to, but just before we hit the 8 o'clock mark, I just wanted to say a heartfelt thank you to everyone that's here. Jim, Kaz, Patricia, Niru, thank you all so much for taking your time to have these discussions with us. Thank you to the CRHNet team for helping to organize this. If anybody here isn't already involved with CRHNet and wants to take part in more events like this in the future, please check out the CRHNet website, get involved, stay tuned. And yeah, just really, really big thanks. I'll let Nathan and Ramona or Sarah say anything that they want to add about CRHNet. If they have anything. No? Okay, if not, then, oh, I see we've got some links in the chat. And I'd love to send out the contact info for all of the panelists in the follow-up email or on the website going forward. with that note, we still have a few minutes of the scheduled time, and I have a question for Dr. Higuchi, if you've got a moment to think about this one. I know that that El Nino has an effect on the oceanic carbon cycle. I'm wondering if you can talk to us a little bit about that and how that we can expect that to impact climate change in the next, who knows how many years of El Nino we've got. Oh, but you're muted.
That's a billion-dollar question. I mean, we have a difficult time. For example, my colleagues at the geography department, and I've been looking at the carbon cycling around Hudson Bay lowlands, for example, right? And things are happening in terms of permafrost melting, the impact of different wind direction with a different temperature regimes on or offshore from Hudson Bay, the role of ice in Hudson Bay. And okay, so the Rick Bello and I published a paper not too long ago about what could happen to the ice in Hudson Bay. And based on energy balance calculation using a so-called NAR data, which is North American Regional Analysis data from the United States, we found out the way the ice is melting in the spring and the wind is freezing in the fall, that there would be a net energy loss from the Hudson Bay. That's a speculation, which means that the ice, you're not going to lose ice total. Some people have said, well, come 50 years from now, there won't be any more ice in Hudson Bay. Well, we don't think that's to be true, but I mean, it is very speculative, and that has an impact on the way the carbon dynamics will operate around Hudson Bay. The PhD student who looked into that, who is now a postdoc at U of T, is in the process of publishing 4 papers based on what the impact might be on the permafrost. And it's not easy. It's very complicated, right? And like anybody else, like anything else, it's very complicated. So it's very likely that we're going to have an increase in carbon emission. But then, you look at one of the most recent paper that came out with the methane, right? People say, well, methane is going to warm, there'll be an increase in the methane concentration. Well, it's going to warm up, add to the CO2. Well, but there was a very, very recent paper that came out and said, no, that's not going to happen. There's a cooling component to methane, right? They minimized what happened up to this point. They minimized the absorption of solar radiation by methane, that they focus on the infrared radiation from the surface only. And so they quoted a figure of 30% cooling effect by the increasing methane concentration. So those are the things that we don't take into account, or it's something that we keep on increasing our knowledge about. And same thing with the hurricane. Just to deviate the question a little bit, Will. The same thing with the hurricane event in the North Atlantic, right? Well, besides the temperature, there's the wind shear, and the fact that the wind regime gets, so-called jet stream gets pushed further south. There again, a very recent paper that came out said that that the wind shear is going to increase. That would then prevent or reduce the formation of hurricanes, besides the heat effect, right? And so what I'm trying to sort of say is that there are all these complication factors. We focus on ENSO impacting precipitation and temperature. While we completely neglected NAO impact, there's an intricate connection between NAO and the ENSO event through what we call a PNA, or Pacific North American Oscillation. So we have all these complicated nonlinear oscillatory dynamics in the atmosphere. So it's going to be very dangerous to say, well, okay, well, you know, we can attribute this to the ENSO event only. We know that NAO and ENSO interact, and we know the Pacific Decadal Oscillation interact with ENSO as well. So, you know, talking about average is fantastic, it's great, but you got to emphasize the variability into that. When you're going to talk about disaster emergency management, you're not going after average. Average, you know, based on historical data, but it's the extreme part that you have to be concerned about, right? And so I really don't want to oversimplify the problem. I've already given you know, a couple of talks to the public in general, right? But because of the Earth Day that's coming up, and I'm asked to give a little talk on Earth Day. The problem is that we tend to simplify the problem a bit, and there's a danger in that. And you know, one of the phrases that we use while working for Environment Canada is that when you're preparing a briefing note for ministers, the government politicians, is that we have to really dumb things down. Dumbing down was a kind of, you know, phrase that we used to use. By doing that, you tend to, I think you lose the nuance, if you will, about the complexity of what we're facing. And disaster management is almost like, you know, you have to fly by seat of the pants, almost. So, and again, going back to the communication is really, really, I began to appreciate that. I didn't really appreciate the communication part of it, but I began to really appreciate the communication, the timely communication. And that's gonna be one of the key elements in trying to reduce the disaster component of natural hazards. You're going to have nature events, they're hazards. The only reason why you have disasters is because humans are not, either they've, you know, neglected to adapt to that. So it's the communication that's going to be awfully important, as other panelists have pointed out.
Excellent, thank you. That I don't really know what to take away from that exactly, apart from that it's a very, very big issue.
It is a big issue, yeah.
I think that we had a question in the chat.
I have a question as well, Willow, if that's okay.
Yeah, please.
So we're right now working on our programming for the symposium that's going to be happening in October in Edmonton. And we want this symposium to be a little bit different. We want it to be interactive learning, actionable learning. We're doing kind of a design thinking method. So within our room, we're going to have practitioners, responders, emergency managers. We'll have policymakers, researchers, the whole 9 yards. I would love via email, and I'll throw my email address up in the chat afterwards, if anybody has any suggestions on some actionable learning workshops that we could do to help for preparedness and to reduce disaster risk due to large and extreme weather events. So really interested in any feedback that anybody would have. And like I said, I'll put my email address in the chat, but would welcome anybody's interest in helping to facilitate that, participating in it, and any suggestions that anyone has. This conversation has been so enlightening for me that I can't imagine that it wouldn't be for many others as well. And you know, part of our mandate is to make sure that knowledge is shared from you know, those in the know. And I just really think we had an excellent group of people today, both from the attendees and the panelists. So I welcome anyone's suggestions on that moving forward.
Thank you. We had Michelle Sullivan in the chat asked, are there, well, Michelle, would you like to ask it yourself, or would you like me to read that for you if you're here still? Let's see. You are. Going once.
Hi, sorry. Yeah. So I guess I was wondering if there are any perks to an El Nino year. Like, but we often kind of move toward the negative because we like to prepare for the worst. However, are there some benefits or perks to an El Nino year, like maybe longer growing seasons or weather patterns that are conducive to certain outdoor activities that could be, you know, like festivals? Could harvest festivals be enhanced? I just wondered if anybody knew of any positive news to an El Nino year.
It's always great to have an optimist on board.
Well, you know, I guess the perturbation itself is it could be viewed as a mostly negative, because system adapts itself to the existing normal, if you will. So any perturbation to that is a disturbance, and how you perturb the disturbance is, it could be classified as a disaster or not. In the same way that climate change is viewed as a negative, well, not everybody's going to suffer equally, or some will gain. For example, there was a report out saying, well, Canada is going to have a positive benefit from global change within the context of agricultural sector because of the increased precipitation. That's what the global climate model says, right? I mean, because of the increased precipitation, higher north, warmer temperature, which means a longer growing period. And the way we talk about it is that 1.5 degree temperature increase. I don't know what that means exactly in the regional scale, but there are positive aspects to that for some people. So if you look at the El Nino example, La Nina, it's not so much the fact that, you know, you have El Nino, La Nina, is that oscillation bad? No, they're not bad by itself, because we have, the system has adapted to that pattern. It's the extreme pattern, if it's going to be negative or positive. Right now, for example, extreme precipitation that we're going to end up in California, well, that's going to replenish what happened during the La Nina, for example. That's a positive thing. So there's a sort of counterbalancing effect. So I think it's a, yeah, so we shouldn't portray ENSO event or La Nina event, whatever, as a negative perturbation.
So can I quickly add to that one positive? In an El Nino year, you get less hurricanes in the Atlantic.
Right. No, I agree. Yes, you're absolutely right. Yeah,
So
because of the shear effect.
Yeah.
I'm so happy we were able to end that on a positive note, because often these talks of climate change just end up going into our demise. I did want to add a few things before we close it out. Thank you for joining. We hope to see you soon at the in-person symposium, which is happening in October in Edmonton. We also want to highlight our CRHNet memberships, which if anyone wants to continue these conversations, great way to support it is by joining us as a member of CRHNet. And you can also continue the conversations onto our Discord, which is linked to that in the chat, or it is on our social media as well. But back to you, Willow, for any final things.
And we'll be sending all of that out via email in the next day or so. So don't worry if you didn't jot it all down.
I want to respect everyone's time. Let anybody leave if they want to. Ramona, you as well as the official host of this. I have a billion questions. I could keep asking everyone here questions all day long, but I don't want to take up anybody's time if you all have to get going. But if you don't, okay, so if you can stay, if you do want to stay, then the question that I have on my mind right now, which I guess might be a silly question, I don't probably know enough about this even to really ask a question about it, but say we have a 7-year El Nino 7 years of unprecedentedly hot summers and rising global temperatures, and we do see a lot of ice melt. What can we expect for coastal flooding, or should we expect and be worried about a lot of coastal flooding as the sea levels rise?
Can I start on that? First of all, 7 years of El Nino or La Nina is an impossible scenario. The data, past data at least tells us, so evidence is there that these are governed by oceanic circulations. So those cycles, and there is a pattern, although you might feel, oh, this was a wacky year, but there is still a pattern that the oceans are, I mean, the planet is 70% oceans, and whatever happens in the oceans, actually that governs the climate on the land. So looking at the, if we learned anything from the past, the recorded history, we don't know really going back to millions of years, although there is evidence. I'm reading a lot of papers that Alberta was a shallow sea 100 million years ago. 1 million years ago, Greenland was green, and there are ice cores and soil cores to prove that. So things like that. In short, universe has a way to govern itself, and those balances in different, in the ocean, the atmosphere and land, they do take place. And you might say, okay, some hypothetical scenario, 7 years of El Nino or La Nina, you might, absolutely, you can think about that, but I don't think it's a possibility. So I'll stop there.
Okay, thank you.
I think we reframe what would happen if we had several, like quite a few years of really intense extreme heat periods, which, I mean, with climate change, we are seeing the average temperature go up quite significantly. So I think rather than El Nino, let's look at what we're seeing with climate change. And I think that goes more towards your question. And we are seeing temperatures climb. We are going to see ecosystems shift over time. Now, it probably won't be 7 years, but if we look towards the studies that are being done on climate change and the models being done towards that, we are going to see kind of a roadmap on what that would look like. So I think the question isn't so much El Nino, it's what will we see with climate change overall? And that's looking pretty scary. I'll be perfectly honest. And it's a frustrating one because I remember being in middle school and being told about climate change and what a threat that was and how it was going to affect our children's children. And now getting to the age I'm at, and my sister has kids, and going, well, wait a second. With my parents were being told that their children's children were being impacted. Well, their children's children are here now, and we're still having talks about setting goals. There hasn't been enough action at this point. So El Nino is one point, but climate change is another part that we have to consider because it's the background that El Nino is occurring against, right?
The point you raised, Patricia, is interesting. And you just talk a little bit about the Arctic, because the Arctic is warming 3 or 4 times faster than the rest of the globe. And the changes, a lot of the changes are taking place there because of the change in albedo. So things that are white reflect the incoming sunlight. But when the snow melts and the ice disappears, of course, it absorbs heat much faster than normal. So the Arctic is warming quite quickly. There's a lot of rather recent research being done on the fact that the Arctic is warming much quicker, on what that's doing to the whole atmospheric jet stream pattern, if you want to call it. And there's been a couple of really recent reports looking at a split in that jet stream. So there's a period or locations, and this study was done in Europe, where the significant increase in the number of European heat waves that are killer heat waves are actually in theory, being influenced by this split in the jet stream caused by these anomalously warm or ice-free temperatures in the ice-free conditions in the Arctic. The other correspondingly, and I'm doing a talk on the weekend for the Nova Scotia Wine Growing Association, because they lost a lot of their very sensitive vines this year because of a -30 event in the Annapolis Valley, which is unheard of in recent years. How likely are we for anomalously cold events because of these changes in the jet stream? And basically, I won't get into the details, but this meandering jet stream, if you want to call it, can bump, and I'm simplifying it, the polar vortex to facilitate this cold air surge like we got in the end of January, early February in parts of North America. And so is there a increasing likelihood of extremes on both ends because of the changes in the Arctic? These are questions that aren't yet answered, but as I said earlier in the evening, how do we prepare folks for things they've never experienced before? And these wine growers are going to ask me on the weekend. Of course, I don't have an answer for them, but it's fascinating but scary.
I think it's particularly scary too to consider how we mount this challenge of communication with a public that is getting increasingly suspicious of science and really, really irritated with the process of scientific back and forthing as we come across new information. With especially with events that are not unpredictable necessarily, but unprecedented and unusual for a public. Like you were like, I can't remember who it was. I think maybe it was Patricia saying, preparing people for things they've never experienced before. When we have to tell them what's going to happen and why it's going to happen and explain science to them that they've never heard of before and that might be contradicted later on by new data. I don't know how we bridge that gap of trust, I guess.
But there's a time lag here, right? I mean, climate change is not going to be occurring next year, and not to the extent that we're going to have a 2-degree global average temperature increase. So there's this kind of lag time, I mean. So there are a lot of factors will come into play during that, say, 30, 40, 50 years to year 2100. There are other factors, and even now, people are more, at least among some of the people I know, are more concerned about possibility of nuclear war than climate change, And so there are, as history evolves, there are other factors coming into play a lot. And, humans have adapted in Earth's history. Human species have existed as a species. They didn't disappear. We didn't go extinct because of global warming. You're going to lose a lot of lives, perhaps. You're going to have there was a PhD student, PhD student who did a thesis at the Faculty of Environmental Studies about the so-called climate refugees. How is that going to affect the geopolitical framework? And that in itself will be, he found that could be one of the major, if not the major, instability that would cause global war, right? Not at 1.5 degree globally average temperature. I don't know what that means exactly, but then, or 2 degree global warming. It's the invasion of different nations, and it has happened before. Some of the invasion that some of the groups of people who invaded Rome, for example, because of the drought that they experienced in Eurasia. So people have adapted, people have survived as a species, not on an individual basis, but as a species. And so if you're going to focus on individual survivability, then that's an entirely different problem. Then you have to view global warming in a different framework or different concept. But as a species, I have a confidence that humans will survive. Maybe 4 billion people, perhaps, I don't know. But so this, I've heard scientists talk about, oh, we're the sixth extinction, the species is going to, be gone, it'll become extinct because of, say, global warming or this, certain ecosystem function will collapse, tipping points and all this discussions. But I don't share that concern. As a species, we will survive. And it's a question of who will survive.
And how.
Yeah, and how, yes, yeah, no, I agree.
Norman, you had your hand up for a little bit. I want to let you have that time if you still want to say anything.
Thank you very much, Willow. And this is sort of the question is, and I think if it doesn't exist, I think it's a great opportunity for the symposium, but is there currently a modeling or planning taking place that individuals, members can participate in that focuses on climate change, that the framework itself takes a area, a city, a area, location, a province, and then play the devil's advocate of introducing a new hazard and then seeing what our capabilities are with that brain thinking of this new hazard, or speaking about a current hazard, but change the increase in damage duration so that where we can start planning is grabbing hold of what is tangible and then introducing through the subject matter experts the what if scenario. There is enough what if scenarios in the world that we could draw lessons from. Earthquakes, we can go to Japan and New Zealand. We can now go to Halifax for Fionas. BC has not been introduced to any of those hazards. However, there is a probability, and that goes back to Patricia's statement, which is the communications tool or method, is that if we're talking climate change and we're introducing these new hazards or making things worse or more damaging, the probability, how you're going to sell that to me is what's the likelihood of? Because if there's a higher probability, I'm more likely to move on to it. If your confidence is higher on that, I'm more likely to inspire on that, because a lot of the conversations we have here has got a price tag attached to it. Because if we're introducing new hazards, we have to look into new mitigations, new plannings, and new trainings so that we can develop new tools and methods to do this. So it's hard to let the pocketbook open when their probabilities are not significant, yet the cost of the impact is devastating. And so my question is just that, is there a current planning session like this available? And two is, what's the likelihood? What's the probabilities that we can start to use to make confident introductions of new hazards?
Wow, well, who wants to take that one on? Norman, I know one thing that we were kind of talking about for the symposium was having a focus on some dark sky events, with prolonged power outages and things like that have been experienced in the last several years that people were completely unprepared for. And, the more extreme the weather, the more probability, to use here the term that you like, that this is really going to happen. And how can people actually manage without any power for weeks, months on end, which is something that could potentially happen. I know we have two more hands up. Jason, I think yours was up just before Patricia, so you can go ahead, Jason.
Hi, thank you. I'm with Radio Amateurs of Canada, and I got to figure out how to put my hand back down. I'll do that in a minute. Norman, what you were saying there is kind of critical, because as a community services officer with Radio Amateurs of Canada, as I put in the chat, one of my jobs is to develop CanWarn training. And what's happened is with communications. And I believe Willa was saying, how do we communicate? We've gotten so technical in communications that there's this huge information highway, but it's not always the right information. It's not directed to the right people. And I've seen this over the past 3 years, and I work closely with, Jeff Colson and others in building these programs and trying to restore this program as a Canadian program, working with Environment Canada and other emergency management groups. It's really difficult to get the information, put it together into training processes because everybody's so busy. They're busy trying to do their regular things and all that. And I'm hoping that over the next year, I'll be able to reach out to additional resources so that our CanWarn training will change to better prepare not just amateur radio operators on how to report the weather and do all that stuff, but work with emergency management groups, work with community groups and create a better focus on how do you prepare for weather? This is important information to have, so on and so forth. So we are working on a process. And again, we'll be running CanWarn this year. So I am looking for people to reach out from British Columbia. We'd like to get more information about the flooding, how it impacted individuals in that, Alberta and some of the heat wave that they got last year. So we can help put this into the program. And, we offer it online, so it goes all across the country. Last year, we had over 400 people, and we're trying to expand the training to meet the needs for the specific areas across the country. And everybody's right. Communications is very important, and it's very difficult sometimes with the world the way it is and everybody busy within their own little sandboxes trying to get things done in that. So I really thank everybody for coming in and doing this. I was a little bit late, but thank you very much.
Thanks very much, Jason, for your input and just information about what you're doing to help with disaster risk preparedness and everything too. So that's really great.
I guess we should give our final word of the night to Patricia.
So Norman asked one of the million-dollar questions for emergency managers across Canada. There may be programs out there. How accurate they are, I'm really not sure. Because like for climate models, like they're run by supercomputers. So I would really be leery of how good a job they would do in terms of being functional for emergency management purposes on top of that. So it really comes down to hazard identification and risk assessment for us. That is actually one of my core areas of expertise, because when I worked for the province of Ontario, I was actually their specialist in HIRA overall. And it's tricky because things are changing all the time, and it doesn't just take climate change. It can take changes in population, new technology, but climate change is taking our old way of looking at hazards and their risk profiles and kind of throwing it against the wall. However, I am not a big believer in black swan events. For those of you who may not be familiar with the term, those are those hazards that people believe are completely unknowable. They just pop out of the blue and there was no way that we could have known that they were going to happen. A lot of the time when someone's talking about a black swan event, there were indicators they can exist. Like, for example, I've seen COVID being referred to as a black swan event, and it's like, no, pandemics happen approximately every 50 to 100 years. It's not unknowable. It was #1 in our HIRA like before COVID. So yeah. In terms of how do we plan for this, it means going into a really in-depth process for hazard identification and risk assessment. And that can be very, very daunting because you're going to have to bring in the physical scientists as well. So, and in this case, the climatologists as well, to look at how things are going to shift for your specific area. There's not going to be a ton of agreement in some cases. Some models may have your area becoming more dry, or others might have it staying fairly similar. It may differ overall, but the more research you can put into it, the more of an idea you can have. Now, the method that I came up for Ontario at that point actually did have climate change built into it with a degree of uncertainty as well. I kept that more broad than frequency and magnitude, because the reality of it is with changing risk, we don't know the impacts it'll have. So there are ways to get kind of an estimate for how it'll work, but in terms of identifying hazards, we can at least come up with a general idea. So for tornadoes, is there some reason you cannot get a tornado? Is it that one hasn't occurred in recent memory? Or is it that they can absolutely never occur? Because BC has had tornadoes in the past before the last one. I'm actually from BC, so that's how I know that. I'm from North Van. It's just that they're really rare, right? So we know they can happen there. So if we look at the evidence with what's coming with climate change, and we talk to the specialists, we can start to put the pieces together, but unfortunately it's going to be a really intensive process. So you can kind of use that to create kind of a proposal for more funding. But the issue is, as emergency managers, we can't do this stuff on our own unless you somehow are one of the lucky ones who has never-ending funds and resources. I could see you laughing already. No one has ever answered yes to that. So I felt that was pretty safe to make the assumption. And that's kind of one of the issues, right? Like we really need a community of others, including the physical scientists, the social scientists, to really help us with this, because this is something that's beyond our scope. And I think that's the way to do it. It's not complete because, I mean, weather and climate are complicated, and how people interact with it is going to make things even more complex. But I think that's probably the best starting point, because I would be somewhat leery of any programs, especially ones that are being sold, because I have seen a few, and especially ones that predict human behavior, because it's like, how did you come up with this? Maybe they're good, but yeah, I don't know. I'd have to see them actually tested and compared with a real emergency to be able to endorse them. Like, I don't know, Jim, have you seen any that would actually meet your criteria for being considered reliable?
No, it's the easiest thing to do is simulate a scenario. So what I mean, for us as meteorologists, because some of these events are, as I said, somewhat difficult to describe if people haven't experienced before, you compare it to something in the past. So the best way to start is take something that has experienced in the past and you make it worse. and so and you know, I did some work with the city of Halifax and the city of Sydney on flood flood mitigation, and they're talking about 50, 100-year events and all this blah blah blah. And I said the worst flood was Hurricane Beth, 1971, 250 millimeters in 24 hours. Take it, and that's what you should use design storms. And so my advice to emergency managers, or in this case was city managers or city engineers, was to take a design storm, which is the worst case in the past, and plan for that in the future. And whatever it be, in our case, it's hurricanes. The worst on the flooding, you talked about coastal flooding. The worst coastal flooding storm in the history of Atlantic Canada was the Saxby Gale in 1869, 2-meter storm surge. The sea level has now risen by another 1/3 of a meter. So you take that same storm with the existing sea level, and the Tantramar Marsh in Nova Scotia becomes an island. So that's the kind of combination. You take the worst in the past and apply it to the future with the new context, because the cities are bigger, the infrastructure is more vulnerable, populations are higher, population is older, so, and it works. And you're not going to get it perfect, but it works.
Could I ask a question?
Yes, please do.
So you do cost benefit analysis, right? In the disaster and emergency management. Is there? I mean, I'm just trying to sort of think about how much loss are you willing to take? Like for example, COVID, right? I mean, how much of you did you expect in designing how to tackle this problem? How much death were you willing to accept? I mean, life is risk, but I mean, there must be some sort of criteria that you choose. Say, well, we can cope with 100 people dying, or 1,000 people dying, or one person dying is too many. So how do you design your approach to sort of address these hazards and disasters?
Probably not the right person to answer this question, since I've never actually worked in this field, only studied it. So please, people who actually have experience, jump in and correct me if I'm wrong. But my understanding is it's less about deciding how much death we're willing to work with, and more about just trying to identify what kind of loss can occur in general and make plans that hopefully take us in the direction of limiting that as much as possible. So
how do how you define loss?
In a lot of different ways. I mean, obviously, like death is loss, injury is loss, environmental loss, economic loss, infrastructure loss. But they're all things that we think about when we generate emergency plans and when we look at HIRAs and create HIRAs. So, I mean, I don't think we think too much really about what loss we can deal with, because it's again, like I said, more about just identifying where losses can occur and trying to think of the best way to limit those. But B, we are working in a field where we don't get nearly as much support as we should for preparation for mitigation. So a lot of our ideas about how to limit loss get ignored. So you do end up having to deal with a lot of loss. But it's less about planning how much we're willing to manage, and more planning how to avoid it and then what to do about it if it does happen, I think.
So ultimately, a lot of the really big measures you can take to avoid loss are not actually made at the emergency management level, unfortunately. A lot of those are made more at the political level or other levels than us. Emergency management, a lot of the time, as Willow said, we're identifying potential opportunities. We're figuring out, for example, our hazard identification and risk assessment, or hazard risk and vulnerability analysis, as it's known in BC and a few other provinces. We're coming forward with options, but ultimately it's up to others, such as our politicians, as to where funding goes. And that's actually one of the big struggles, because if you have a council, they have a ton of competing demands at this point and a limited budget. And if you have crumbling infrastructure, such as a bridge, versus funding for mitigation, which often, I mean, it can be a hard sell, right? And personally, while I want funding for the emergency management program, it's not always going to go the way the emergency manager wants. So we can push for emergency management. We don't always get our wish with that. And that's one of the struggles our field has, that we don't necessarily allocate the funds that our field is advocating for. It comes from higher levels of government who actually are responsible for things like the infrastructure that gets disrupted and the equipment that the responses are dependent on. Does that make sense?
Yeah, but these are the kind of questions that insurance companies must ask. I mean, they're looking at 50 years, 100-year projection. How much money are they going to invest in terms of ensuring certain infrastructure deaths? So and I just wonder because because I didn't know how, because I don't know how people decide on this. It's just like an area that I haven't got a clue essentially as to how you proceed in this kind of decision-making process.
It's called risk tolerance. At least
Okay.
that's what we call it. It's actually a really interesting area to look into it, to see the different levels of risk tolerance and how people develop that. It's very frustrating though, to read about it. Because the earthquake in BC is really kind of the ultimate example of that, because we know that there is a very high potential for loss, and you look at the risk tolerance and it doesn't really align with what we know the potential losses are. And that comes into differences in perception, biases. So it really is a fascinating area to look into if you're interested.
It also gets really complicated and also very interesting and sometimes frustrating to consider the nuances of something like insurance, because so much of emergency management and like city emergency management planning has to do with looking at the infrastructure resources and the key aspects of a city that are often privatized. And so whether or not they're insured is something that's up to that private person. So like the TTC, for example, if it breaks down tomorrow because of some kind of horrible disaster, how much control do we really have over dealing with that as emergency managers?
Yeah.
Yeah.
Well, yeah, I was thinking about this because a couple of days ago I read an article about the war going on between Russia and Ukraine, and number of people dying, number of people being sacrificed, and the writer sort of posed the question as well, how many deaths is Putin going to accept, or before the country, as Russia, going to accept? So you talk about the loss for the achieving this ultimate objective of conquering Ukraine. And I thought, well, it's sort of like a disaster scenario, right? War is a disaster. And so there has to be a certain expectation of loss. And so I just wonder if how that could fit into sort of on your discussion about natural hazards, for example.
I think that is fascinating, and we could talk for ages and ages on it. I mean, I would say Putin's probably not following a logical mindset, but most people aren't. And on that note, I do think we should end it here.
Yeah.
We have gone a bit over time. I do apologize for that, but thank you so much for everybody for coming out. So.
Well, thank you for the opportunity.
No, thank you.
Thank you so much, Kaz and Patricia and Ramona and Sarah and Nathan and everyone else that's here that I can't see that's off screen.
And thank you very much, Willow, for all the efforts you put into this, for coming up with the idea. It's clearly been a topic that people are eager to talk about. And so, emerging professionals are rising stars, and we have several of them on our committee, including Sarah, who's been very quiet to stand, and Nathan and whatnot as well. And so I encourage all of you existing professionals to keep an eye out for some of these people, because they're going to be your co-workers really soon.
Especially Willow.
Yeah. No, about that. But yeah, and as Nathan has said, if you have any further questions, if you want to keep chatting, join the Discord, throw questions up. Someone will see it, someone will respond. Obviously, we're all eager to chat. So yes, thank you so much. Hope to talk to you all again in the future.
Thank you, Willow. Thanks, everybody.
Thanks, everyone. Take care.
Thank you.
Thanks, guys.
Hey.
That went well.
That
We're all
did.
internal now, so thank you, seriously, everybody. You guys just
wait,
freaking
Mona?
rocked it.
Can you just end the recording before?
Oh, yes. Thank you.
Thank you so much